How about all the above? Let's start with writing, because that's something where you really need to make the long-term investment. And I learned early on that you need to write every day and to devote your best concentration hours a day. It's kind of like saving money. You should pay the bank first, and you should pay your writing time first, because if you wait till it's something left over, you don't get the writing done and you don't get the saving done. And that's something I've taught my students, and I think it really pays off, because you get in the flow of thinking and pulling things together. And similarly, it keeps the research going, because when you hit a block on one thing, you move on to the other, but you need to build a community around you, and you need to get people into similar kinds of habits. I've been running larger and larger research teams over the last 10 years, and find that you've got to have weekly meetings at minimum, and then various side meetings to get other pieces going. But it really matters that you lead by example. And if I'm writing every day, I can get my students writing every day. And if I'm editing their materials and getting them back to them, then I can get them to the point where they will critique my materials. And I think that's been the real productivity of our research team, is people have gotten into a flow where they can critique each other, and they're willing to sort of stand up to power. They will critique my work just as much as they will critique others, and we all learn from each other in that way. So Liz, you wanted more of a background of how I got into this complex field in the first place. I came by it honestly. My mother was a librarian, and I grew up in the back stacks of a university library. And then I got a degree in mathematics, and in the 70s, your only options were really programming or becoming a high school math teacher, neither of which was particularly interesting to me. And my mother recognized that libraries were going to be facing technology and did not have the workforce. And she was scared to death of computers, but at least she recognized that was going to be needed. And she was right. And I went to the University of Pittsburgh to pursue information retrieval, and found that they really did not have people with the math and computing backgrounds coming in. And it turned out to be the right place at the right time, because I came in just as information retrieval systems were really taking off. And my first job was to automate the Dallas Public Library. So we, in the late 1970s, we actually wrote that in assembler language on the city's mainframe. And not only did we turn the card catalog into an online catalog, it was probably the first distributed online catalog. Because we'd done it on the city, we had made it available on every dumb terminal on everyone's desk for every city employee, and gradually spread out from there. What I learned from that process, besides a lot of technology and collaboration, was that the hard part was not the technical design. The hard part was the human-computer interface. And nobody had any idea how you really designed a terminal so that people could walk up to it, had no computing background whatsoever, and be able to ask a question and make sense of what came out the other side. So that's what led me to get the PhD in communication from Stanford, which was a very technology-driven program at the time. I mean, it's still a very fine program, but they've gone off in different directions in the interim. But it led me into this mix of computer science, communication, the information retrieval, but also the commitment to libraries and books and materials and helping people find their way around information and information management. My current research area is hard to describe because it wanders through all of those areas. The key words would be things like scholarly communication, data, information retrieval, digital libraries, social studies of science and technology, a bit of digital humanities, and a bit of bibliometrics thrown in. It's probably easier to explain by example. Is for more than a decade, I've led teams of students and postdocs to follow scholars around and interview them and try to understand what their work practices are. And in doing so, we're trying to understand what are data to them, where data fit into their work practices, how they publish, why they publish, what they're willing to share with whom and when, how they collaborate, and then to feed this into the design of better information systems, better knowledge infrastructures, and also to address this large array of policy issues, because the funding agencies, publishers, and others are pressing people to manage their data, write data management plans, release data, reuse data, and nobody really knows how to do that. So by working with them directly and understanding their community of practice, we're able to come up with design solutions, but also to respond to national and international policy.
Great. So how is publication changing among scholarly researchers?
Well, the obvious way that it's changing is it's going digital. And it's gradually been going digital for several decades. But I think we've shifted from the dual publication of print and digital to being almost entirely digital. So that's kind of the obvious part. But what's not obvious to those who sort of don't live and breathe it is that the publications are then proliferating in versions. So there's some versions you're allowed to share, some you're encouraged to share, some you share anyway, and they get posted on institutional repositories, on publisher sites, on personal websites. Hard to bring those back together again. But then they're also getting broken up into these little tiny pieces. So the figures and the tables and maybe even the bibliographies might get different digital object identifiers, and those might get deposited in SlideShare or Figshare or Dataverse or the Protein Data Bank or the Social Science Data Archive at UCLA or someplace else. And bringing those back together again so that you can reconstruct the evidence and reconstruct the history of scholarship, that's what's changing so fundamentally. And I think that's where the challenge is as far as being able to manage one's own data, find anything else, or see what's going to be curated and made available for the long term. Well, the data I will try to be succinct, but just having written a 500-page manuscript on the topic, this is the book we talked about before. It's coming out in January from MIT Press, called Big Data, Little Data, No Data, Scholarship in the Networked World. And there I've really tried to build upon the teamwork research that we've done for this last 10 or 15 years and frame the problems and do case studies in different fields, and then come back to the problems of releasing, sharing, reusing, and getting credit and discovery and attribution for data. The scholars tend not to think about what are their data up front. If you're in some place like genomics or in astronomy, you're very conscious of sort of data as things that you create and things that you use. But then when somebody comes along and says, well, release the data, it's still not clear what are the data. Is it the observations I got? Is it the things I pulled from an archive? Is it the spreadsheet? Is it the clean data? Is it the documentation? Is it the descriptions? Is it the metadata? Is it the provenance? And as you move into areas such as qualitative social sciences with lots of human subjects involved, it's very hard to know what the boundaries are of your data and what you can release. A lot of this is very, very sensitive if we want to get into the ethical issues later. It's not at all clear what part of that are data, what part of that's documentation, what part of that falls under any of these data management plan rules, the kinds of liabilities, risks, and responsibilities that go with it. You move over into areas of the humanities, and very few people at all are thinking about the evidence and materials that they work with as data per se. But when you start interviewing them and asking them about how they do their work, often I find that people's reaction is, well, I never even thought about those as my data. And then when the funding agencies come along and say, write a data management plan, so is that what they're talking about? Do they want my little scripts? Do they want my tables? Do they want my notes in the archive? Do they want my photographs? That's my dowry. I'm not giving that away. That's not just something that's attached to a journal article. It's something very different. It's my scholarship. And there's just this fluidity between what's your scholarship, what's your personal materials, and what a funding agency or an archive might think are your data. So the whole notion of data management, information literacy, if you will, is around what people consider to be their data in the first place. Because there are very few definitions of data will you find in these policies. It's pretty much anything your field considers to be data are data. So unless we pin that down, we can't pin down the rest of it. So I'm thinking ahead to some of the questions for the students you want to reach with these videos is we try to help scholars think about what are their data in the first place, to get them to think about what's worth keeping, how long, for what reasons, and who might use it in the future, what else it might be used for. Because the sooner in that process they start thinking about those things, the more likely they are to add metadata, add documentation, add description to them, begin to document some kind of a provenance or chain of custody, chain of changes to those particular materials, so that as they go through a life cycle and proliferate into other documents, other work products, you can begin to follow them. Because if you don't do it early, you're never going to be able to come back later and be able to track those pieces down. So the question is, you're a graduating senior, and you're going off to graduate school, off to a career, off to adventures that you have no idea where you're going, and you may end up in a field that didn't even exist when you were an undergraduate. I would say that most of your course materials and many of your travels and forays may turn out to be very useful evidence and material for you to use later. You want to come back to that textbook, that paper you wrote, those materials you dug up, whether it was from a paper archive or the project you did in chemistry lab or biology lab. And keeping those notes in such a way that you can go back to them may allow you to repurpose them later in ways you never expected. Let me give you an example. When I left the Dallas Public Library, I worked for a brief career in private industry as a programmer analyst for a credit database company, writing personal name algorithms for databases of 100 million personal names, which was a very difficult problem by the late 1970s, as the linguistic variation was growing in the U.S. pool. And that's part of what led me to be a privacy advocate, is realizing how bad and how ugly those data were and how badly they were managed. 15 years later, the Getty came around looking for someone who could help them disambiguate artist names as paintings were traded from one part of Europe to another, and as Tiziano became Titian, and as Rembrandt's name was rendered as Rembrandt van Ryn, and various other combinations. And it turned out that what I knew as a systems analyst working on a credit database was expertise that nobody else in digital humanities had. And we did some amazing work, and then that work the intelligence communities come after me for. wanting to know how to leverage that. If I didn't have good notes and good background material I had pulled together for working on that credit project, I would not have been able to leverage it into an art history project or into other kinds of data mining. And the kind of data mining expertise now, in many ways, trickles way back to that work I did in automating card catalogs. Okay. So just because, what you did now for, how could I possibly use that? And that's exactly what scholars are facing, is that they're not managing their data in ways that they can make sense of it later, much less anybody else, because they can't imagine who else might use it and for what. They might start with my 2007 book, Scholarship in the Digital Age, which will give them a broad sweep of that changing nature of scholarship and notions of access to information and discovery. If they want to understand some of the sort of the history of the data and what that means, the broader one of the forthcoming, the big data, little data, no data of mine, might help them get started. If they want to think about information seeking and use, Donald Case's book, I think this is called Information Seeking and Use, is probably the best broad sweep there. The difficulty with this area is we don't have that much in the way of canonical pieces. It's, some of it's, if you want the good computer science text, we can send you there. If you want the information retrieval text, we can send you there. We don't even have particularly good introductory texts for people wanting to be librarians or archivists either. So it's kind of scattered in a journal literature, and it's very hard to know what to point people to. Well, it does. The difficulty, the very fact that I'm having difficulty with it after 30 years in the field should tell you that it's a mess out there. But it's also partly the community practices background issue, that the way we seek information in chemistry is vastly different than the way we seek information in history. And coming up with by the time you come up with the lowest common denominator, you've got something that's useless. And I think that's the reason we don't have a good general introductory text. But it's also the problem with information systems is Google, Bing, Yahoo, what have you, are optimized for selling you things. And a search for Canon will get you a camera and not the Buddhist canon. We used to have specialized search engines that would take you to these narrow areas. If you really want to get to those narrow areas, you've got to go to the databases that are specific to those fields and have the vocabulary and the descriptions to let you narrow down on very fine questions. And for those, you're going to be back to the reference desk to find a really good librarian, a really good archivist who's going to help you, who's going to mediate between the question and the material. Because as far as a very general way in, it's communities of practice. Because the terminology, what the word file means is different between computer science, libraries, archives, metallurgy, you name it, in these different areas.
Great.
People use the same words to mean different things and different words to mean the same thing, and that's the nature of rhetoric, and we are never going to get beyond that. That's the fundamental problem of information retrieval. Big data is all the rage, much more hype and hyperbole than substance. It's better to have the right data than more data. And making the haystack bigger does not make it easier to find a needle in it. So the questions of big data are really, really messy because it's big relative to something. You don't have to have a terabyte of data for it to be big data. If you are an archaeologist accustomed to working in a few square meters and suddenly you're working a few square kilometers, you are drowning in data. A few megabytes of data can be a lot to somebody who's working with little bits and scraps of papyrus. So first off, big data is a relative term. And secondly, having lots of data creates its own problems. The data wrangling, making sense out of it, cleaning it up, figuring out what questions you can ask, appears to consume 3/4 of the effort in making use of it. Getting insights out of it is very hard to do, and it's also very hard to replicate. Okay, so people will do these massive studies, write these custom algorithms to make sense of one data set, and then they have a hard time repurposing those rules on something else. Okay, so it's this continuous process. I mean, that's why I titled the book Big Data, Little Data, No Data, because there's fields like astronomy that have literally terabytes. Sometimes they produce terabytes of data a day flooding at them. But it's always been a field with large volumes of data. They simply keep scaling and finding ways to manage it. But at the end of the day, there's a fair amount of small data or little data there. They'll start with this big archive of things coming off the Hubble or the Sloan Digital Sky Survey and take their piece out of it. But once they've taken their piece out of it and massaged it, mashed it up, maybe they've combined it with something they've got from their own observing time on another telescope, we're finding that stuff sitting on servers under a desk in the next building from here, because it ends up looking just like the archaeologist data or just like the humanist data. They have just as much trouble managing those small bits of data. And then they end up, having no place to go because nobody wants them back. The big archive doesn't want it back because you've messed with it and you've done all kinds of things and it's not our data anymore. So our archaeologists, our metallurgists, our people in Class 6 that we work with, they've got a similar kind of problem of, as soon as they get to more than they can handle, any data that's more than your tools can handle becomes big data. And then they've got to find new ways to ask new questions and massage it. My Buddhist philologist, who I hope you get to meet someday, his name is Stefano Zacchetti, and he is Italian. He did his first degree in Italy in philology and Chinese studies at a time when you could not write Chinese characters in good text. So he did the Italian, left big spaces, and did calligraphy. No digital version exists of his dissertation with the calligraphy. Later in his career, he did a massive critical edition, 500 pages, all in PDF. It's written in Chinese, the old Chinese characters, in Sanskrit, in English. I think there's maybe a bit of Japanese in it because it came from a Japanese center also. That, of course, is a massive amount of data, but because it got locked into an early version of PDF that is basically a camera page image, he has no structured version of that he can work with. Now, the Buddhist monks have digitized the entire, I think it's 55 main volumes and 80 supplemental volumes of the Chinese Buddhist canon in full XML markup, in Unicode, and then he's got other sources he can go for old Chinese character scripts. He can search all of this in a way that he never could before. So now he's got this telescope, as he says, he can see farther, and his microscope, he can see closer. But at the end of the day, he's still turning out journal articles with a column of Chinese and a column of Sanskrit and elaborate notations at the end. But now he can manage them. Now he's got something, a product that he can go back and reuse. But part of the lesson there is, he was not able to think at the beginning of those earlier projects about how he might save it and how he might reuse it, and he lost it. Whether he even could have saved it, is another question. But he wasn't even really thinking about how he could save and use these data as big data until he and I started these long conversations. And in my trying to understand how one does scholarship in Chinese 3rd to 5th century Chinese Buddhist philology, he also came to think about his own scholarship in a new way. And gradually after some months of conversations, we got around to being able to say, well, this is the data, this is the documentation, this is the interpretation, this is the part that's evidence, this is what's ephemeral, this is what I'm going to keep, and this is why. But it's getting scholars, getting students, getting teachers, getting anybody who handles information, and who doesn't these days, to think about what they've got as data, to think about it as information as early in that process as possible. That's the real challenge. Well, this is a good time to be thinking about that problem, because you're going to be thinking about that for the rest of your life and the rest of your career. And you're going to be thinking about it not only for your professional materials, you should be thinking about it for your family photographs, your financial records, and others, is to expect that anything in digital form is going to rot and disintegrate in a much shorter period of time than you expect. You're going to have to migrate it to other kinds of media and other kinds of technology. You won't find, you don't find floppy disks anymore. It's hard to find the CDs are even beginning to go away. The USB ports are changing. The FireWire ports are changing. You've got to be able to keep moving things to other media. So no matter what you put them in to manage them, keep them in some fairly standard, fairly open, portable formats. Word is okay, PDF is okay, XML is okay. None of them are great. Good to do paper copies on acid-free paper where you can. It depends on what needs to be kept most discreetly for how long. But don't assume that any piece of software is going to last indefinitely. Also, try not to skip generations of technology, because it's very hard to go back a couple of generations, and you're into digital archaeology, which is a position you don't want to be in, and it's going to be very expensive to get it back later. So think about what you've got, think about it as information, document it in multiple ways, describe it, keep track of what it is, where you got it from, put some dates on things, put some key terms, put some descriptions on them. Don't make it too elaborate, because you won't maintain it. Keep it elaborate enough that you can find things again, but not so sophisticated the whole system's going to break down very quickly. And assume that whatever you manage is going to be a continuous, long-term process. This is not going to be like putting that box of grandma's letters in the attic for your grandchildren to find. Those days, for better or worse, are behind us. That goes back to the knowledge management questions and the tensions over sharing data and releasing data, and the differences in communities of practices between fields. In early days of management information systems, companies came along and said, oh, let's build knowledge management systems. Let's document all the expertise our employees and put in a database. And so everybody can find who else has what expertise. And guess what? Everybody wanted to find other people's expertise, but they didn't want to put their expertise in because they were afraid they'd get replaced. Once I've done my data dump, why should you hire me? You don't need me anymore. And you've got similar kinds of concerns in scholarship of, if I document everything absolutely completely and put it in a database, do you need to keep hiring me and need to keep paying me? Which gets us into some of those differences between fields. In genomics, people are able to describe much more discreetly what the data set is that goes with this paper, and might deposit it and then go on to the next thing. Where in the humanities, the research is much more cumulative, and the sources of evidence they take to that particular paper, that particular book, they're going to be slicing and dicing in different ways for the next book. That set of expertise materials, they consider to be their dowry. and I really do hear terms like dowry, they're not going to deposit those with each paper, and they certainly can't slice them up in ways that there's a one-to-one mapping between a data set and a piece of paper or a journal article and move it on. So the notion of big data, little data, and where there's no data at all because people don't have to release it, they won't release it. There's proprietary data you can't get your hands on. I was talking to an urban planning transportation engineer recently that said they can get their hands on the city planning data for transportation systems, but they can't get the trucking data. And they can get the taxi data because it's regulated, but Uber and Lyft won't give them their data because that's their dowry, that's their proprietary information. They're not about to let their business model out.